Dr. Sprons, and for today we're talking about inverse variation, which is a type of relationship between x and y variables in mathematics. Hello everyone, this is Dr. Sprons, and for today we're going to be talking about inverse variation, which is a type of rational expression relationship in mathematics. From our previous lesson, we talked about direct variation, wherein if input is increasing, output is also increasing. And for today, we're going to be working on a different type of relationship between two quantitative data sets, which is called inverse variation. And according to the definition, y varies inversely as x, or y is inversely proportional to x if there is a non-zero constant k such that y is equal to k all over x. So it's a little bit too much to handle for some students, but this is actually just the context clues that we're going to be using to answer word problems for today. So when you see varies inversely as a description of the relationship between y and x, we are going to be using the formula y equal k all over x this time, where k is called the constant of variation, or in this case, constant of proportionality for relationship involving inverse variation. Now, from our previous lesson, we used y equal to k times x for a relationship considered to be direct variation. And if we have inverse variation, we're going to be using y equals k all over x instead. So to understand this type of relationship better, let's have some examples of relationship involving inverse variation. One of them is the number of vaccinated individuals in an area varies inversely with the number of COVID-19 cases, which means, just like what we talked about on the previous slide, if the input is increasing, the output is decreasing. So if the number of vaccinated individuals is increasing, our number of COVID-19 cases will decrease. And this is a type of inverse variation in this particular relationship. We also have the speed of a moving car varies inversely with the time it would take to arrive at a certain location. And the number of hours sleeping varies inversely with the time spent on engaging in social media, which means if our input is decreasing, our output is increasing. So there is a change on the direction between y and x in this type of relationship. So let's answer the first word problem that involves this type of relationship. And in this case, according to our first example, if y varies inversely as x, find the constant of variation k and the inverse variation equation given that y is equal to 63 when x is 3. So to answer this word problem, the first clue is already given to us, which is y varies inversely as x, which means this is our prompt to use the formula y is equal to k all over x. And in this particular problem, we're looking for the constant of variation k and the inverse variation equation. So we are given y and x, which is 63 and 3. And what we're going to do is to use the formula y is equal to k all over x, where y is 63 and x is 3. So in this particular problem, when we use y is equal to k all over x, all we need to do is to replace y by 63 and replace k by 3, and by cross multiplication, we'll be able to find the value of k. And 3 times 63 will be equal to k, and by multiplying this, we know that this is equal to 189. So now we have our constant variation that is equal to 189, which means we're now ready to solve the second part of our word problem, which is finding the inverse variation equation. So again, by using the formula, we replace x and y with 3 and 63. And by cross multiplication, we're able to find k, which is 189. And using our formula for inverse variation y is equal to k all over x, all we need to do now is to replace k with 189 so that we'll be able to write the inverse variation equation in this problem, which is y equal to 189 all over x. So this is how we use this formula in this type of relationship for this example. So let's say we have a table of values as our given problem. So in this case, we need to write an inverse variation equation of the form y is equal to k all over x that will satisfy the given ordered pairs. So here we already know that we're going to be using the formula y is equal to k over x because it says here that the relationship is inverse variation. And it's also true because by just looking at our table of values, just like what I've mentioned, if input is increasing, output is decreasing. And in this case, the input is increasing, therefore the output is decreasing. So if I have x is equal to 2, notice that my output is 6. But if my input is 4, my output is equal to 3. And if my input is 1/2, my output is even bigger, which is 24. So since this is an inverse variation, all we need to do is to pick a point, any of those points. I'll just choose the first one, which is 2 all over 6. And in this case, I know that my point 2 and 6 represent x and y in my equation. So using the inverse variation formula y equal to k all over x, I will replace the value of x, which is 2, and replace the value of y, which is 6, so I can find the value of k by cross multiplication. And by cross multiplication, we multiply 6 and 2, and we'll have 12, which is the constant variation that we are looking for, so we can write the equation of inverse variation relationship for this particular table of values. And in that case, all we need to do is to replace k with 12, and now we have a specific equation that is particular to this relationship in our table of values, which is y equals 12 all over x. So this is how we use this formula. Again, you just need to look for the keywords so that you would know what type of formula you're going to be using to find the constant of variation that will help you write the equation that you are looking for. And now let's say we have this type of word problem, which is a little bit complex compared to the other two because this time we're using a different variable. So in this word problem, the volume V of a gas varies inversely as the pressure P on it. Now, if the volume is 240 cubic centimeters under pressure of 30 kilograms per centimeter squared, what pressure has to be applied to have a volume of 160 cubic centimeters? Now, our word problem is a little bit text heavy, so what we can do is just work on each of the statement and try to answer each statement so that we can organize our work. So here, we know that the volume V of a gas varies inversely as the pressure P on it, which means we are seeing our keyword, which is varies inversely. So we know that we can use y is equal to k over x in our formula. Now remember that this formula, it's read as y varies inversely as x. That's why y is equal to k all over x. And in this word problem in particular, we're seeing volume V varies inversely as P. That means if we're going to translate this verbal statement into the formula that we have, y varies inversely as x, therefore, from y equal to k all over x, we can have a new set of formula that is specific to this word problem, which is v equals k all over p, because P or pressure is our input and our output is our volume. And now that we have our formula specific to this problem, we are given on the second part of the statement the volume of this particular equipment, which is 240 cubic centimeter, and the pressure of 30 kilograms per centimeter squared. I'm just dropping the unit of measurement so I can focus on the numerical value that I will be using, so that now I can use my formula to solve for the constant of variation K specific to this problem. So since I have V equals 240 and I have P, which is 30, using V equals K all over P, I know that I can replace V with 240 and replace P with 30. And now I can do cross multiplication so I can find the value of K. So 240 times 30 is equal to K. And we know that the product of 240 and 30 is equal to 7,200, which is the constant of variation that we're looking for. And now we're ready to solve the rest of the word problem that we are working on today. So by looking at our equation, we have V is equal to K all over P. I replace V and P, and by cross multiplication, I found 7,200 as our constant of variation specific to this word problem. That's why we can now answer the last part of our word problem, which is looking for the pressure that needs to be applied to have a volume of 160 cubic centimeters. So in the last part of the problem, the volume is given and we are looking for the value of the pressure or the amount of pressure needed so we can have a volume of 160 cubic centimeters. So now that we have our volume, which is 160, and we also have our value of K, which is the constant of variation at 7,200, all we need to do now is to cross multiply and answer this problem. So how is cross multiplication going to work in this problem? So let's say I have 160 equal to 7,200 all over P. By cross multiplication, all I need to do is to switch P and 160, and I'll have P equals 7,200 all over 160, and the quotient of this two is going to equal to 45. So now that I have my value of the pressure, the value of P, which is the pressure needed to have a volume of 160 degrees, I'm now ready to solve my word problem. So I cross multiply and found that 45 kilogram per centimeter squared is what I need to produce a volume of 160. By writing it down to answer the word problem, we have this as our statement for our answer to this word problem. We need 45 kilogram per centimeter squared of pressure to have a volume of 160 cubic centimeter of gas in this particular equipment. So this is how we use our new formula for today, which is y is equal to k over x. And this is specific to this type of relationship, which is inverse variation. That means if your input is increasing, your output is decreasing. So for our Numberbender challenge for the day, let's see who can give me an example of relationship that is considered to be inversely proportional. So I have given you 3 different types of relationship from our first few minutes. Now I want to hear from you and see how many of you can list down relationship that is considered to be inversely proportional. So this is how we work on problems involving quantitative data, wherein if your input is increasing, your output is decreasing. So this type of relationship is called inverse variation, and this is the second type of relationship on rational expression that we're working on in this lesson on algebra. This is Dr. E, and see you again next time. Bye!